Look at the bathymetry readings on the hollow map. The incline is steeper than projected. We need to adjust the entry point slightly south. Copy, adjusting the survey markers now. Okay, move the prism to grid reference C-4.
Got it, setting the pole now.
Looks stable, locking the measurement.
We need to verify the alignment against the baseline. Hold on, I'm getting a slight deviation on the rover.
The compression test results are unstable at this depth.
We must inspect this section closely before they begin excavation.
The current route impacts the aquifer. We must reroute. Can we shift it 5 meters to the east using the optimized model? Let's look at the geological impact.
Bring it down 20 feet, watch the clearance on the left side.
Roger that, coming down slowly.
Keep coming straight, easy now. Watch the clearance on the left side. We need to secure that upper section before the next phase.
Roger that. Keep the perimeter clear.
Seismic data confirms this section is stable enough for the initial blast. I agree. Supports are secured. All right, signal the drill team to commence operations.
We are hitting a high-stress zone on the left anchor.
Yes, the pressure is fluctuating. Adjust the feed rate immediately.
We have full contact pressure on the face. How are the geophones reading?
Reading stable, continue advance.
Sensor data confirms stability. Proceed with controlled excavation. All personnel maintain safe distance.
The rock stability here is lower than projected. We need to adjust the drilling angle immediately.
Hold it right there. Watch the clearance on the left. Okay, holding steady. We're good on the alignment. Secure the bolts.
The shear wave velocity is dropping significantly right here.
Confirmed. The GPR is showing a major anomaly. We need to bolt this section immediately.
Watch the clearance on the left. Bringing it up slowly. Secure that bolt now.
We are deviating slightly north. Adjust course by 0.02 degrees.
Confirmed. Depth remains constant at 800 meters. The laser shows we are right on the mark, 500 meters out.
Confirmed. The coordinates match the plan exactly.
All right, team, let's keep it moving. Remember safety first. Always wear your gear and follow the instructions. Watch the welding sparks.
Look at this hairline crack right here. The thermal reading confirms a cold spot. We should schedule the resin injection for this section.
The pressure ratings are stable here. Good, let's verify the gradient on the next segment.
Watch the pressure gauge right there, keep it steady.
All right, firing up the pump now.
The thickness looks consistent here.
Yes, the laser profile confirms it meets the specifications.
Lower it slowly. Watch the clearance.
The drainage looks clear, but the safety systems need recalibration. Let's log that immediately.
I'll check the pressure gauges upstream.
Alignment confirmed. We have a breakthrough.
We did it! Great job, everyone. Control, this is Section 5. We have a confirmed breakthrough. Fantastic news, engineer. Amazing work.
The segmentation looks solid here.
Agreed. No visible stress fractures on the lower ring.
We need to ensure the TBM is fully calibrated before the next push.
Absolutely. The geological data for this section is critical.
The strata analysis shows increased water pressure ahead.
Acknowledged. Slow the advance rate and monitor the bolts.
Truck 4, you are clear on the green light. Proceed with caution to the entrance. Watch your spacing.
The scan shows consistent RQD values across the face.
And the discontinuity measurements look good. I'll sign off on the report.
Excellent. I'm authorizing the next cycle.
Okay, that one's secure.
We can move to the next position.
Keep the pressure steady. Moving to the upper section now.
The thickness variance here is acceptable.
within the 5% tolerance.
Good. Log that section as completed on the tablet.
Pull it tighter on the left. Okay, I got it. Watch the chain. We need more cable down here.
Bringing the spool over now.
All right, hold it steady while I connect the ground.
We have confirmation. We are now under the fjord.
Begin rotation sequence. Steady pressure.
Base, initiation sequence successful. Stand by for data.
The tomography shows a significant anomaly at 50 meters. Possible water ingress zone. We should recommend a probe drill here.
The thermal imaging shows consistent rock density here.
Yes, the route is stable. We can proceed.
All right, tap the approval. Let the crew know we are greenlit for drilling.
Adjust angle by 2 degrees. The laser is off. Copy that. Adjusting feed rate.
Charge 44 is secure. Clear for the next sequence.
Confirmed. Move to sector Gamma 6. Watch your step.
Attention all teams. Final safety checks complete. We are initiating the countdown. Clear the area.
Levels are dropping fast. We should be clear in 5.
Copy that. Advise when ready for re-entry.
This fracture zone extends deeper than anticipated. We need to reassess the bolt pattern.
Okay, marking that down. What's the RQD nearby?
Alignment confirmed.
The new trajectory looks good. We've passed the previous record depth.
Keep the pressure steady. We push another 200 meters this cycle.
Adjust trajectory slightly starboard. Confirm depth reading at 500 meters.
The route alignment is confirmed. We have a perfect match. The deviation is negligible on the z-axis. We are clear to proceed.
Make sure the tension is correct on this section.
It's secured. We checked the torque.
Check this seam. We need absolute integrity here.
Check. Pressure is holding steady. Looks good.
All right, moving on.
Confirming the slope on channel B. We have 98% efficiency. Proceed with installation. Pressure readings stabilized immediately. Diagnostics are showing green across the board.
We need to ensure the gradient is correct at the overlap. Yes, I see that detail in section 4. It looks aligned.
The flow rate is acceptable. Continue vibrating the mix until it's fully settled in the segment.
The quality here is exceptional. The waterproof barriers are perfectly installed. Absolutely, this section is ready for the next phase.
Confirming strata analysis. We are clear to proceed with the next bore.
Over.
We've reached the target depth of minus 255 meters.
The granite is harder here, but the progress is steady.
The dimensions here are slightly off the projected line.
Let's rescan this section before the next drill cycle.
The structural readings are stable here.
Good. Let's proceed with the expansion as planned.
We have stabilization on Sector 4.
Acknowledged. Engineers, confirm measurements for the facility space.
Check the alignment on screen. It looks slightly off tilt.
The laser scan confirms it's within tolerance.
We're ready for the next anchor now.
According to the simulations, the airflow distribution in this section is optimal.
Good. Ensure the foundations meet the seismic requirements.
We have a pressure drop at section 4. The airflow isn't stabilizing. Confirmed. The levels are critical. Adjusting the intake manifold now.
We're showing a deviation on the alignment here.
Check the structural integrity of the upper quadrant before proceeding.
The LiDAR scan confirms the reinforcement is holding perfectly against the water pressure.
Excellent. The drilling trajectory looks clear from here to the midpoint.
Control room, this is passage 4. We have reached the required depth at connection point 2. Stand by for laser alignment check.
Alignment confirmed on the east heading. We are within tolerance. Proceed with the next support ring.
Check the torque on bolt 73. Looks good on the schematic. We can move to the next section.
Okay, center it right there. Check the alignment on the screen.
Looks good.
Holding steady.
We're clear to move the main distribution frame down to section 4.
All right, I'll notify the crane operator.
All right, push it up higher on your end. It's heavy. Is that bolt secure yet?
Sensor aligned. Readout stabilizing.
Temperature is steady at 22. Air quality nominal.
Check the structural integrity scan. Looks good. Radio check. Section 4. Loud and clear. Signal strength optimal.
Control, this is Unit 4. Evacuation route integrity confirmed. Signal strength is optimal.
Data log updated. All readings green.
All right, let's keep moving.
The monitoring systems show green across the board. Emergency passages are fully operational now.
This is a major milestone for the project.
As you can see, all systems are green across the board. The ventilation readout is stable.
Excellent work, team. This section is ready.
The lux reading here is consistent with the specs.
Spacing looks good on the tablet. We can sign off on this section.
Secure the red phase cable to the T2 block.
Secured. Torquing now. The fiber optic link is secure.
Good. Let's run the diagnostic on the ventilation controls.
Okay, I've got the camera secured. Are you getting the feed on your end?
Yes, the image is stable. Let's check the zoom calibration now.
Sensor alignment confirmed for Sector 4.
Acknowledged. Data stream is stable.
Torque is set on the bolts. Good. The airflow stabilization looks nominal on the schematics.
Initiate smoke sequence now. Monitor the sensors at checkpoint 3. We have good draw.
Watch the clearance on that pipe. Almost there, keep it steady. We need the drill over here now. The reflectivity on this segment is within tolerance.
Yes, but check the humidity readings over here. Check the alignment on the left side now.
Okay, hold it right there. That's perfect, keep going.
The flow rate is consistent with the projection. The subbase seems stable. Agreed. The data confirms structural integrity for the long term.
The alignment is drifting slightly to the right.
Adjusting the guidance system now.
Keep moving the rod slowly. Right there, what's the reading?
0.5 millimeters. Perfect alignment.
How's the depth on this yellow line looking, Supervisor?
It's perfect. Keep the machine steady and maintain the pace.
All systems green. Command. Proceeding to Sector 4. Confirming all signage is active.
Control, this is Team 1. Radio check.
Loud and clear on frequency 2. How's the fiber link status?
Fiber link stable at 100 gigabits per second. The voltage on panel 4 seems stable.
Confirmed. Thermal readings are all within tolerance. Let's check the backup array. We have achieved maximum flow rate. Check the overpressure warning on screen 3. Reading confirmed. System holding stable at 120 pascals.
Control, this is Alpha Team. Heavy smoke conditions at Section 4. Ventilation is active.
Roger. Alpha Team, proceed to the nearest emergency exit immediately.
Sector Charlie, report status on extraction.
Extraction proceeding. Victim stabilized. Requesting transport ETA.
Transport ETA, 5 minutes. Keep the tunnel clear.
Flow rate holding steady at 50.
Pumps are clear. No cavitation.
System is fully operational.
Today's. The concrete integrity looks solid, minimal microfractures. Data confirms stability across all segments.
Welcome. We are pleased to present the final safety certifications.
Excellent. Let's review the stress reports and the structural integrity data.
All reports are satisfactory. The safety protocols are met.
Agreed. It's fully certified for public operation.
Check the lux levels on that marker, please.
Reading 350. Radio check complete, signal strong. Control, this is Unit 1. Data streams are stable.
Copy that. Confirm nominal across all systems in Section 3. Final systems check complete. Communications clear. Roadway conditions optimized. Ready for opening sequence.
All right, lift that rig another meter.
Roger that, going up.
Engineers confirming the barrier placement on the south side.
We are live at the site of the ManufactureXplore project, the longest undersea tunnel in the world.
It represents a monumental leap forward in engineering.
The ribbon-cutting ceremony marked the culmination of the massive ManufactureXplore project, years ahead of schedule.